Hello everyone, so today's question is called palindrome partitioning. Given a string, we need to partition the string in such a way that every substring of the partition is a palindrome. So for example, if this is the question AAB, so if we partition, if we do two partitions, that is after this A and this A, then we'll get A, A, B, and all these three substrings are palindrome, so this is fine. Next, if we partition after two A's, then also we'll get two palindromes, right? So this is the question. Now how we'll solve it, we'll be using backtracking. Now why we'll use backtracking is because we need to go and search for every possible substring. Whenever there's questions where you have to go through all the substring, then we generally tend to use backtracking. If the question was something like just find number of such substrings, just find number of such partitions, then we would have used dynamic programming. Anyways, that is beyond this question now. So if the question is AAB, we'll partition over here like this, okay? So that is our first partition. The second partition is after two A's, and then final partition is after the entire string, which is A, A, B. Okay, we can make, basically I'm trying to say, we can make a partition over here, we can make a partition over here, and we can make a partition after the string. Okay, so our motive will be we will search that if the first parted element substring, that is, if this is the question, if this is how we partition, which is A, and then we have AB, right? So if the first parted substring is a palindrome, then only we'll move to the next, that is you can say if the left parted substring is a palindrome, then only we'll move to the right parted substring. Okay, so for example, in this question, when we are parting over here, so A is a palindrome, right? So since A is a palindrome, we'll move to AB now. We'll check if we can partition AB now. So we'll see for AB. Okay, now again we can part this AB two ways, that is one over here and then one over here. Okay, so we get A and B, and we get AB together, right? So again we'll check for this partition. We'll check, okay, is A a palindrome? Yes, A is a palindrome, so we'll go ahead and check for B now. Okay, for B, yes, B is a palindrome, and now that right parted element, there's nothing in right parted element, we'll stop our partitioning here. Okay, now backtracking, we'll go to the above step and we'll check for AB now. Is AB a palindrome? No, AB is not a palindrome, so we won't go further. Okay, coming to this partition, which is AAB, now again we'll see that AA, the first, that is the left parted substring, yes, AA is a palindrome, it is. So now we'll go ahead and check for B. Sorry, something is wrong over here. Okay, I have written something wrong. Anyways, this is actually wrong. We'll check for B now. None of this will come. Because I don't know why I wrote it that way. That is what I did wrong was I was again partitioning AA. We won't do that. We know AA is a palindrome, so we'll now go ahead and check in the left parted substring, which is B, and we know that B is a we just did it over here the same way. B is a palindrome, and even if we part, it's a single alphabet, so nothing forward will come, so we'll stop it there. Now this substring the third way how we parted was this. Now again over here, since right is empty, we can't do anything and we'll stop our partitioning here. So this was the basic structure. Now we'll go ahead in coding, and I guess when I write it down, then the things will get a bit clear. So the first thing we need to do, these 4 statements which I'll write now is very common when you write a backtracking question. For a backtracking question, that is, since we need to return a 2D vector, so I'll make a 2D vector and call it res, that is result. Now I'll make another vector and call it answer. So this will hold each and every parted element like AAB, and then AAB, like this answer will have these vector, answer will have this vector and then this vector, and this is my final result vector. So we made 2 vectors, and then we'll finally call a function. Let's just name it helper function, and here we'll pass our result vector, 2D vector, answer 1D vector, and the position from where we'll start partitioning, that is 0. Now this I'll explain again while I write the helper function, and we need to pass the string. So yeah, finally we'll return result because that is what is needed. Now using this function helper, we'll start adding our strings in this result function. Okay, so I'll write like void, because we won't be returning anything, we'll just be pushing it in the vector. So void, and then result then answer, and then finally we'll say, let's name it start. So we'll say int start comma string s. Next, once this is done, okay, so we have the string now. Now what we are supposed to do is we'll take each and every like first, as we parted, like we had A, B, right? So we first took A from that, and then we took A, another A, then we took B. So we'll do similarly. So if no how to write, okay, I'll just say string, and let's take a temp variable and we'll initialize it empty. Now for int I equals to start, and I is less than the size of the string, because till that only we can partition, that is if the question is AAB, then I can only partition it till the last partition which we did was like this, AAB, and we can't partition further, right? So that is why we'll go till the length, and then I'll say that I'll take temp and I'll append each alphabet of string in temp one by one. So I'll say now temp is having A right now, let's say. So now what we have to do, we need to check if that is the right parted which we have right now in temp. If it is a palindrome, then only we can further proceed with this temp, or else we'll go ahead and take the left parted string. Okay, so I'll just take a function called let's name it palindrome check. If it's a palindrome, we'll write this function later. So if it's a palindrome, and we'll pass this function string temp. Now if string is a palindrome, then we'll say, alright, now we can push this temp in our result, right? So answer. So recording just stopped. So I was saying if it's a palindrome, so if it's a palindrome, then we can simply now it's a palindrome, so we can simply push it in the answer. So answer dot push back temp, right? Now once temp is pushed, now for example this was our question A. Now if A is pushed, we need to go ahead and check for the right parted substring, right? For that is AB. So I'll do the same, and I'll write this function. I'll use the same function, helper function V, and I'll call it res comma answer. And now start. The start will be, so think if I was over here, that is I was at A first, and then it moved to this A, right? So it will be I plus 1, because we are done with first alphabets checking. We are done. We checked it if it's fine or not, if it's a palindrome or not. Now we need to move ahead, so we'll write I plus 1 and comma S, because the string won't change. We need to pass it again and again. Now answer dot pop back, because once this A and this is checked, now we need to pop it back, and once this is completely popped and this partition is gone, if it's AAB for example, and then this is partition and it's done, then we need a fresh answer and we need to start it over again, and then we can partition it like this, right? That is why we need to pop it back. Basically this is something we do usually in backtracking. As I said, this is the backtracking question. In backtracking you always need to backtrack and go back to the original string. So this is what I'm writing, to go back to the original string. So yeah, so this was the helper function. Now yeah, this is the entire solution. Oh, we need to write the function for palindrome check. Now I just wrote it, but recording stopped, so I'll write it again. So palindrome function, I'll just say palindrome. One second. So this is the code for palindrome check. So what we are basically doing is we are taking 2 pointers at the end and start of the string, and we will be traversing it, and if ever I is not equal to j, we'll simply return false. Then we'll say if it was equal, if it was equal, then simply I will increment and j will decrement, because we need to travel like both the pointer needs to come at the center. So if it has finally successfully traversed the entire array, it will come out of the loop and it will return true. So that was the solution. I'll do a little rundown again. So what we are basically doing is, this is something which you need to write always for a backtracking question. Now how you will identify the given question is a backtracking. So a question is always a backtracking when you need to travel the entire string. Like over here we knew that for finding each partition we need to travel entire string, because if we did it till here, we won't know. Like if I partition till 1a, I won't know that if the the left part is a palindrome or not. So in such cases, when you know that you need to travel entire string, entire array, or whatever the given parameter is, then we use backtracking. So this is like something you write almost in every backtracking question. Then there is a helper function. The helper function code is also generally similar, like these lines, like this line is very common, then this line is very common, and then you will use the same recursion function, and then this line. These lines are very obvious, like very almost in every backtracking question. It may change or variate as per the question, but it will usually be like this only, that you will travel from one starting to end, and then you'll have a condition. If it's satisfying the condition, then you'll push it in the in the smaller vector, and then you'll recurse it again, and then you'll pop back from smaller vector, and then finally if it satisfies some other condition, you'll push that smaller vector in this bigger vector. So yeah, thank you so much for watching.